Oh, good catch.
I always forget about that.
Oh, yeah.
Mhm.
Okay. Did you have any of the first four that you had a question on?
I I missed a couple points on one and two, but I worked them out. Let me pull that up real quick. Um, on one, I messed up algebraically towards the very end, and I got 4 instead of 8/3.
Oh, okay.
Um, and then on two, I forget what I did. Wait, what did I do? Two. On two, it must have been illegible because I couldn't even read it, but I missed points. What did you get for the integral for two? Actually,
I got the integral from -1 to 2, integral from x squared to x plus 2, and then the function is x squared minus y dy dx.
that's exactly what I got. Actually, both times. So, did you get all
Uh,
points on that?
yeah, I did. So maybe you
I think
should email him and just say got the
I
right
didn't.
answer.
I didn't write it legibly apparently on the last one.
Oh,
I
that's
think I
okay.
did like x equals and y equals for each of the bounds, just to be formal, but I couldn't really fit it. So
Oh,
I did miss the points on like 4B.
okay.
What exactly is the moment of inertia? Is it the M or is it the Y?
Um, it's the m or the y. So
Like
the moment of inertia about the x-axis, or is it y-axis that it asks for?
it was
Y-axis?
about the X. It was yeah.
Uh, no, I think it asks for y.
As for Y, that would
Wait,
probably be Y.
no, wait. That says x-axis. The moment of the thin plate about the x. Oh, okay. The one. No, that doesn't make sense. Give me 1 second. Oh, okay. The one about the x-axis is the m sub x one, and it equals the integral of y times the density function times dA.
Yeah.
Is that
Okay.
what you had as well?
Yeah. All right. Sorry. One more time. I had like mx equals like double integral x times the density function dx dy, that's how I did the bounds.
Okay.
It
So
doesn't.
it's actually y times the density function instead of x. So
Wait, is it
when,
that true?
yeah, when you're finding the moment about the x-axis, then
The
like
radius
the formula
y,
is the radius, right? And so y is the radius.
right?
But it's also confusing because if you're finding y bar, then you use the m sub x one, and then y is in the double integral equation, and so it's
Mhm.
confusing.
Okay. Okay, so I got to redo that one. Okay. All right.
So if
That's
you just
probably
redo it with y in there, I'm sure you'll get the right answer.
because I think that's what I wrote before. Oh no, I just did the second moment. Whenever I'm like doing physics, so I always think of the moment of inertia as like the rotational moment because that's the only one you essentially use, unless you're
Oh,
trying to find the center of mass, which we never did, but we did sometimes. I don't know.
yeah, it
Okay,
makes
so
sense.
that makes more sense. So I just got to remember y bar has y in the integral, but it's mx over m instead of
Yeah,
right and y for y. Got you. So I'll redo that. That should be
that's
easy.
I know, and that's what makes it so confusing is that it like goes back and forth between them.
Right.
X, Y, X.
Okay. So I didn't miss anything else until 8 or 9.
Okay, on number 5, I got half credit on both of them,
Okay.
which I think is maybe because what is what is your integral?
Um. Okay. So I changed it to polar coordinates. It's actually
Okay,
kind
I
of
did too.
like I used to hate changing things to polar coordinates because I would always do it wrong. And it would always be frustrating. But now it's kind of getting easier.
Yeah.
Um. But I got v equals integral like the theta integral from 0 to pi over 2, and then integral from 0 to, what was the radius? I think it was just 1.
Yeah, I think just
1. And then it was r cubed d theta.
r cubed.
Because the inner function is x squared plus y squared. And it's always dA, which equals dx dy is always r dr d theta.
Okay, so I had r dr d theta and I never put the r squared back in.
Yeah, so you just, okay. So it's r cubed dr d theta.
Okay, and then for my bounds, I have 0 to 2 pi. Is that what you had, or?
It is only the first quadrant.
Oh, is that in the problem?
I believe so. Wherever it is in the problem, I don't remember writing it down apparently. So,
huh? Okay.
Oh, so that was just the original bounds. That's what I got it for. It only goes from 0 to 1 in the x-axis, and then 0 to like the upper bound of a hemicircle or semicircle.
Oh yeah. Okay.
So it only ends up being in the first quadrant.
Okay, that makes sense.
Yeah. So the original x and y bounds determine that.
Okay. And then for B, what did you get? Oh, is B just solving that integral? That'd be why I got it wrong. Never mind. I'll just work that on my own.
Yeah, and I got pi over 8.
Okay.
I don't know if you want to write that down or anything.
Yeah, I'll write it down to make sure I get it right. Okay. Okay, 7B, I got half credit as well.
7B, I think I did good. The weird thing, the weird thing about, okay, 8B was a weird thing because I got 7 completely correct. So 7B, what did you get for the Jacobian of 7A? Like, what did you get for the matrix?
I got 2, oh wait, in 7A?
Yes, yeah.
Oh
wait, that doesn't have anything to do with it. My bad. What did you get for the matrix in 7B? My bad.
So I had 1/5, -2/5, 2/5, and 3/5.
Okay. Yeah, that's what I got too.
So those are right. Oh, you know what I did? I did 3/5 plus 4/5, but it'd be 3/25 plus 4/25, right?
Yeah, and it's 7/25 is the answer.
7/25. Okay.
That's the whole.
Oh man. Okay. All right. Let's look at number 8. Okay, I got half on part A.
I got half on part B. Okay, so we'll just help each other out, I guess.
Okay. So,
this one took me forever. It's hard to think about what they're doing because you have to like rely straight up on their formulas, and it works out nicely. But
so the answer to number 8 is just a picture, right?
Yeah. What did you get for the bounds on the UMV?
I got 7 and 14 for both of them.
7 and 14 for both of them?
Yeah.
How did I get full credit? Because I got from U is from 5 to 10.
5 to 10?
Oh, okay. Okay, got you. U is from 5 to 10, and then V is from 1 to 2.
Weird. Mine weren't even close.
I think I tried a bunch of different ways, and it was just like it got really boring each way.
It was just a lot of algebra.
Yeah, it's a ton, and if you don't do it right, you can't even get the answer. So
yeah, so I didn't get any credit on B. So actually, I can't help you with that.
Okay. I don't even know what I did on B to get half credit, but
what did you have for your integral?
I did, like the double integral of 5 dx dy over region R equals integral from 1 to 2 in the V integral, and then the integral from 5 to 10 of 7/5 du dv, because 5 times 7/25 is 7/5. So that's just the inner function, It's just the function times the Jacobian is the new integral, with
yeah.
differentials. But Okay, I'm trying to remember what I did on 8A. I remember like, okay, so when you have your x and your y in terms of u and v, what did you get when you solved for u and v?
That's a really good question.
Just think that's what comes up.
So like x equals some function of u and v. Is that what you're asking for?
That's what we're given. I'm wondering
Okay.
if you like you can do it a different way, I think, but what did you solve for u and v in terms of x and y? Like
Yes, I did. And I got u equals 7 and u equals 14.
7 u equals 14.
And I got the same thing for v, which I thought was weird when I did it. I was like, that doesn't make a lot of sense.
Huh.
So, okay, so you plug in 3 times u minus 2v over 5, right?
Right.
Plus 2 times u plus 3v over 5 equals 7. And then you solve that.
Yeah.
What did I do?
I think you do them one at a time. I'm trying to remember what I did. I think you plug in for x or y with their terms of u and v, and then you substitute for u in terms of v and y, or like vice versa.
That makes sense.
So like it's u, v, and y on one side, and then you. This is where it gets weird for me because it's tricky. It's really tricky. So I'm gonna go from 3x plus 2y equals 7. Wait, sorry. Wait a minute. Oh yeah. I'm gonna solve for u on the x equals u minus 2v over 5.
Okay.
So u equals 2v plus 5x.
Oh, okay.
Then you use. I'm trying to remember. Then you switch to the other equation and solve for v.
Okay.
Do you actually? I don't remember. This is so tricky. I can't even.
Okay.
So 5y plus minus 2u equals 3v. No, I can't even. This is so. Uh, I can't even duplicate what I did before. This is just to teach us a concept. I remember this is how I learned like why polar is a thing and why you have to have an r inside the dA function or the dA differential. It's because it's the Jacobian of like r sub x, r sub v or something.
I just figured that out this week. I was like, oh, that's where the R comes from.
Right. And that's like now that we do spherical coordinates, I'm like, oh, so rho squared sine of like theta or something, or phi,
Yeah, I think, yeah.
like rho squared sine phi times g rho
It's just
d
the Jacobian.
theta. Right. So
Okay, I think I can solve it from here. I think I can figure that out going off of how you started.
yeah. So and I don't even remember. I just know that the right functions for u and v are like u equals 15x plus 2y all over 7.
Okay.
And then v equals y minus 10x over 7. And then like plugging in for u and v, like you'd find like everything would cancel out when you plug it into the equations, the 4 equations that were the bounds in x and y. And they would just be like u equals a constant and then v equals a constant both twice. And that would be your box.
Okay.
So I literally can't even go back over my algebra. It's
Me
such a
either. Mine is like it's like unreadable.
um, and so I don't get it though. So using the Jacobian, it's just like I got 7/25 is the Jacobian, and the new U and V bounds are the bounds.
Yeah.
So
And you got A right, right?
yeah,
So you know
okay,
your bounds are right, and you know your Jacobian is right because that was from number 7.
right,
So, and then I have 5 also for my function, so I agree with that.
yeah. So it should be 5 times 7/25, which is my Jacobian,
Right. So you get,
PV, right?
yeah.
And PV to U, it actually doesn't even matter the order. So
Well, it would matter the order, wouldn't it? Don't you need to match the U with
as
the,
I did match the U and the V.
okay. Yeah, I guess it doesn't matter. Yeah, it doesn't matter the order because they're both constants as long as they're matching.
Right. So
I can't see what you could have possibly done wrong there.
I don't even know. So I'm just gonna rewrite it and hope that he takes it.
Yeah.
Maybe I'll email him about it. That sounds like an email him problem.
Yeah, I think so too.
Okay.
Okay.
um. So 9. I got 3 out of 13 on this one, but I think I
Okay.
figured out what I did wrong, or else I think I did.
I got it all right. So
You got it all right. What did you get for the answer?
I got 0,
You got 0.
which always scares me when I get 0 for the answer. I'm like, oh crap, that looks wrong. But this time
Okay.
it was right.
Then my correction is also wrong.
Oh.
Like the first time I got -16 thirds, and then I got 16 thirds. For my correction, I got 16 thirds minus 4 pi because I tried doing it in polar this time.
Oh.
So the answer is 0, right?
Yep.
That's funny.
Let's see.
How
I'm
did
trying to.
you? Okay. How did
I
you? How did you do it?
okay. I had the integral from -2 to 2, integral from 0 to the square root of 4 minus x squared,
Okay.
and then the function uh, 3x dy
3x.
dx. Yeah.
Huh. I got 2 minus y.
2
So
minus y.
yeah.
Okay.
I don't even know at this point.
Okay, so let's go back to is it the gradient of f?
Gradient of f.
Yeah.
I think it's what was it? It might be gradient. Wait, what was? What?
It's
Okay. I had the formula like written down explicitly for some reason. It's like negative f dots d over dy comma negative d over dx. Is that okay? So that is just I
hmm,
wrote
that's
that with it. I think that's a more explicit version of what to write.
I think you're right.
But it's also double integral of gradient cross with f dA. Is that the double integral? So the curl of f dA.
I think that's
So did you write it in
um,
component form?
I did the
The M and N.
Green's theorem that's like m sub x
Yeah.
plus n sub y.
Okay. So wait, n sub x, m sub y.
Uh-huh.
So the y component, you take the partial with respect to x. So n to the x, or is it n to the y?
N to the y. There's a different one that is n to the x. This one's n to the y.
Okay. So this is what I have written down. What should it be? Should it be m or n first? And should it
So
be,
that one is another one as well. That one is for flux, I think. Um,
oh, is this not flex?
or maybe this one is flux and that one is for circulation. I don't know. There's one for circulation and one for flux. And this one,
Okay. It's good to know.
should Show how to use Green's theorem to evaluate the integral clockwise. I don't know which this is asking for. You probably do better than I do.
Well, you got it right. So whatever you solve for, you get. So let f equals this vector field. Show how to use Green's theorem to evaluate the line integral curve over integral over c f dot nds along the counterclockwise oriented curve that consists of line segments.
Okay, I have.
This doesn't even say which one it is.
Yeah, I have on my formula sheet somewhere f dot nds. Okay, that is flux. Okay, so the flux one is
Over a curve.
I don't know if you can see my paper. So okay, I'm kind of covering part of it. Oh, is it backwards on your screen? It's backwards on mine.
It's straightforward. I think it flips it on your screen, but not on mine.
So where it says like lesson 4, that first line under that.
Okay.
So the flux is f dot nds. Maybe it's the second line. And then there's one formula that's like mdy minus ndx. But Green's theorem is the one that's m sub x plus n sub y. You see that one?
Yes, somewhere. Is it left?
I think so, yeah.
Y. So f dot m sub x plus n sub y equals, yeah, okay, line integral m dy minus n dx. Got you. Okay, so that fits. Okay.
Yeah, so these are like a bunch of formulas that are all equivalent. So
got you. Okay. So I wrote that completely backwards for both ones. So and like Green's theorem, I must have written a different theorem altogether, both like in the second time. So is this right now?
one sec. Can't. Okay, there we go. Yep, that's right.
Okay.
Except, oh wait, is it the double integral?
Yeah. Forgot the second integral. My bad.
Yeah, it's the double integral.
Dope. Dope.
Okay.
I'm not one of those guys. Maybe I am.
So, yeah.
But I am. Okay. Going off of that. Yeah, both times I got it wrong. Okay. So I'm just gonna say it's flux because so flux is double integral over region R m sub x plus n sub y dA. So where A is bounded by the curve and F is given. So, which is m sub x plus n sub y is just gradient dot with F, right?
Yeah.
So I'm just gonna write gradient dot with F equals, whoops, I shouldn't put brackets on it. Equals 2x plus x.
Yeah.
Oh, so that's where you got the 3x. So that's the inner function. And then the region bounded by the curve is literally, well, you can see that it's like the top is 4 minus, like square root of 4 minus x squared, and the bottom is 0. And then it goes from -2 to 2 for x. So,
yeah.
So R is 0 or -2. Okay, -2 less than equal x less than equal to 2. And then 0 less than equal to y less than equal to square root of 4 minus x squared. Okay, so your double integral was -2 to 0 square root 4 minus x squared 3x dy dx.
Yep.
Okay, that is better. That is not something I had before for both of them. You can even try polar, but that would suck a little bit, not too much. But
yeah, I didn't do it. You definitely could do it in polar, but I didn't.
it would be a little strange. It's just pretty simple this way. So 2 to 3x, or this is what? Okay. X Um, 4 square root of 4 minus x squared. Okay. Just solve this real quick. So negative 3 halves equals negative 2x with 4 minus x squared dx equals negative 3 halves. Times 2/3 4 minus x squared 3 halves from negative 2 to equals 4 minus negative 2 squared 3 halves minus 4 minus 2 squared 3 halves equals 0. Done. Haha. That's fun. Sorry.
Awesome.
Cool. So it works out.
Okay, I did number 6 last, so I have another question on number 6.
Okay.
What were the bounds of your integral? I think that's all I need.
Number 6. Pull that one back up. 6. Find the area under r equals 4/3 theta, where 0 is less than theta less than 2 pi. The area is double integral of dA equals, so for the bounds, I just took what they had, and it would be from 0 to 2 pi for theta, and then it would be from 0 to 4/3 theta.
And then RD theta.
Yeah.
Okay, I should have realized that that's what it was. Okay, so it said bounded by the spiral and the x-axis, the positive x-axis.
Oh, that was weirdly worded.
Yeah, so I took it as well, here, I'll show you.
I think I did that too, but then I ran into a problem and I was like, wait a minute, this could be so much simpler.
Yeah, so I did just like the portion of the spiral that is like bounded by the positive x-axis right there.
Yeah, by the positive x-axis, like, but it's so weird. I think they meant bounded below to the right of the positive x-axis. So
Yeah.
I did from.
So you do the whole spiral, I guess.
Yeah. So from x-axis to x-axis, I guess. Is that all they give us? I remember how weirdly worded that was. That was kind of dumb. Oh, okay, I just ignored the x-axis part. It just said from 0 to theta to 2 pi. So
Okay.
I just ignored anything that said x-axis, and that works, I
I'll
guess.
email him and tell him that it was a bad problem and I want my points back.
Yeah, I like that actually. Yeah, so x-axis, like anything that follows that term, and then you try to do the domain, like you try to make the domain based off of the x-axis thing, but then it gives you the domain of theta. So
right, and I should have realized that it said in the problem 0 to 2 pi. If I had read the problem again, I probably would have.
Right. So I just straight up did from 0 to 2 pi and ignored the x part.
Okay. All right, I'm sure I can get it from there then.
Yeah.
Okay, cool. Well, I think that's everything then, right?
Yeah, I got a 10 out of 10 on number 10. So
I think I did too.
that was actually kind of fun seeing pi a squared. It's like it's the area of a circle, and I was like, hey, that was what we're trying to. That was such a weird way to find it.
Yeah. Like, okay, did we really have to go to all that work just to the area of a circle?
Yeah.
Okay, cool. So we're gonna meet Saturday afternoon to go over the exam, and then that's it for today.
Yeah.
Okay, cool. All right. Well, I'll see you on Saturday then.
See you then.
Bye.
Bye.